Hello students, welcome back to another geometry video. You know what to do. Pause the video, try these problems in your notes, and then unpause them to do them with me. Okay, so first we are asked to find the measure of angle 1. So we're asked to find the measure of this inside corner of the triangle. Now, in order to do that, we could use the triangle sum theorem to do that, but I don't know what 3x is. I know what 40 is, but I don't know what 3x is. Now, there were multiple ways that you could have gone about this problem, but the way that I'm going to do it is I know that this exterior angle needs to be equal to the sum of the two non-adjacent interior angles of the triangle. So I know that 3x plus 40 needs to be equal to 5x minus 10. Now if I subtract 5x from both sides, I get negative 2x plus 40 equals negative 10. I can subtract 40 from both sides, and I get negative 2x equals negative 50. And if I divide by negative 2 on both sides, I get x equals 25. Now, I'm not done yet. I wanted to find the measure of angle 1. But if x is 25, I can figure out what 3x is, or I could figure out what 5x minus 10 is. Now, we could figure out either of these things, because if I figure out what 3x is, well, these three angles, 40, 3x, and 1, need to add up to 180 degrees. Or we could say 5x minus 10 and 1 make a linear pair, so they need to add up to 180 degrees. Whichever is easiest for you. I want us to get some practice with the triangle sum theorem, since we learned about linear pairs back in chapter 1. Let's focus on the triangle sum theorem. So I want 3x. That means that this is 3 times 25, because x is 25. 3 times 25 is 75. Think about it in terms of quarters again. 3 quarters is 75 cents. So now, I know that 40 plus 75 plus the measure of angle 1 needs to equal 180 degrees. So I'll do 180 minus, what is 40 plus 75? 180 minus 115, which is 65. So the measure of angle 1 is equal to 65. Let's check. Let's check and add up 40 plus 75 plus 65. Ah, yes, 180. Awesome. Okay, so first problem, measure of angle 1 is 65 degrees. Okay, next, find the measure of each acute angle. So this isn't just, so we could use the triangle sum theorem on this, but we can also use the corollary to the triangle sum theorem, because this is a right triangle. We have the box in the corner, which tells us that this is a right angle. Because it's a right angle, we have a right triangle. And because we have a right triangle, the two acute angles are complementary. Complementary meaning they add up to 90 degrees. Okay, and now we just need to solve this equation. So 2x plus x, we can combine our like terms. 3x minus 6 equals 90. Let's add 6 to both sides, and we get 3x equals 96. Let's divide 3 from both sides, and we get x equals 32, because 9 divided by 3 is 3, and 6 divided by 3 is 2. So x equals 32. But are we done? No. No, we're not done, because we need to plug in the x. So I'll take 2 times x, or 2 times 32, for the top acute angle, and I'll take 32 minus 6 for the bottom right acute angle. So 2 times 32 is 64, and 32 minus 6 is 26. Degrees, of course, because we're talking about the measures of angles. Now we can check. 64 plus 26 is 90. And then if I add this right angle, plus 90 is 180. So 180 degrees in a triangle, and the two acute angles add up to 90, are complementary. So that's wonderful. Yay! Okay, thank you for reviewing last lesson with me. Now, let's move on to what we have for today. Today we are getting into 5.2, the second part of chapter 5, which is about congruent polygons. So, our learning target for today is I know what corresponding parts are. We learned about corresponding angles in chapter 3. Maybe corresponding parts are similar? I don't know. We'll talk about it today. And you know what the Third Angles Theorem states. Third Angles Theorem. What could that be? And our success criteria for today is that you can use corresponding parts and the Third Angles Theorem to solve problems. So, let's jump right into some vocab words. What are corresponding parts? Well, corresponding parts are a pair of sides or angles that have the same relative position in two congruent figures. Relative position, that's like when we had our transversal, we looked at angles with the same relative position. Bottom left, bottom left. So again, corresponding parts also have the same relative position, but now we're not talking about two lines and a transversal. We're talking about within two congruent figures. So for example, we have triangle ABC and we have triangle DEF, and we can see that they've color-coded. Red is for A and D, blue is for B and E, and F and C are in green. So you can see that they have matched. A has one tick mark on that angle, and D also has one tick mark on that angle. Angle A is congruent to angle D. And likewise, angle B is congruent to angle E. They both have 3 tick marks and they're both in blue. And C and F are also congruent because they have 2 tick marks and they're both in green. So, because, notice how all of the sides too, the side between blue and green has a tick mark on it as well. The side between blue and red have 2 tick marks on them. And the side between red and green have 3 tick marks on them. So, and the reason we use different numbers of tick marks, or like where there's 1 tick mark here and there's 2 tick marks here, is because this side and this side are not the same. If we just used 1 tick mark for both of them, we'd be saying that they're the same. And they're not the same. So we're saying that the sides with 1 tick mark are the same, the sides with 2 tick marks are the same, and the sides with 3 tick marks are the same. So that's why we use different numbers of tick marks. Okay, so you can see in these pictures of triangle ABC and triangle DEF, all of the sides are the same and all of the angles are the same. that means that these figures, or these triangles, are congruent. And so these numbers over here on the left are super, super important. If two triangles are congruent, then all their corresponding parts are congruent. So if I tell you, if I don't mark up these diagrams, I don't draw any of the tick marks, I don't color code at all, but I tell you that triangle ABC is congruent to triangle DEF, you know that you can draw all these tick marks. If two triangles are congruent, then all their corresponding parts are congruent. And it goes the other way too. If all the corresponding parts of two triangles are congruent, then the triangles are congruent. So in our example, or in this picture, in these two diagrams or triangles, we can see all of the angles are congruent and all of the corresponding sides are congruent. So we know triangle ABC is congruent to triangle DEF. So it goes both ways. If all the corresponding parts are congruent, then the triangles are congruent. And if the triangles are congruent, then all the corresponding parts are congruent. Okay, we're going to see an example of this in just a second, but first, I want to share some important information with you. CPCTC. What? So, our book doesn't explicitly state this theorem, but it uses it later on. So I want to explicitly state it so that you know what CPCTC is. And I know it's a mouthful. CPCTC. And CPCTC is an acronym that stands for corresponding parts of congruent triangles are congruent. So it's what we just talked about on the last slide. We talked about it. If two triangles are congruent, then their corresponding parts are congruent. So we have a short acronym for that, that is CPCTC, that if two triangles are congruent, then their corresponding parts are congruent. So corresponding parts of congruent triangles are congruent. So it means that once two triangles are proven to be congruent, then the three pairs of sides that correspond must be congruent, and the three pairs of angles that correspond must be congruent. So, if triangle ABC is congruent to triangle KLM, then all the corresponding sides and angles of the triangles are congruent. So, if you have two congruent triangles, then all the corresponding parts are congruent. Okay, let's wrap our mind a little bit more around these corresponding parts with our first example. Example 1, identifying corresponding parts. So, the question asks, write a congruence statement for the triangles, and then identify all pairs of congruent corresponding parts. So we kind of have a part A and a part B here. So, part A wants a congruence statement. Now remember, back in chapter 1, when we talked about congruent segments, we would say that JK was congruent to what? Let's see, J has 2 tick marks, and T has 2 tick marks, and S has 3 tick marks, and K. So if we're going from 2 tick marks to 3 tick marks, on the other triangle we need to go from 2 tick marks to 3 tick marks. So we can say that segment JK is congruent to segment TC, and you've seen congruent statements like this written before. But now we want to write a congruent statement for the triangles. So what we're going to do is take the first triangle and write triangle LJK. You can write it in whatever order you want. Pick a corner pick a corner from the first triangle and just work your way around. L, J, K. If you wanted to do L, K, J and go this way, that would be fine too. But I noticed we have 1 tick mark, 2 tick mark, 3 tick marks. So I just went in order of 1, 2, 3. L, J, K. Now, we're going to write is congruent to, because this is a statement of congruence. I'm stating 2 triangles are congruent. Now, when you write the next triangle, you must go in the same order that you did for your first triangle. So we went L, J, K. We went 1 tick mark, 2 tick marks, 3 tick marks. So if we did that for the first triangle, we have to do that for the second triangle. So R has 1 tick mark, so we'll write R first. T has 2 tick marks, so we'll write that second. And S has 3 tick marks, so we'll write that third. And see how they go in the same order. I have L, J, K, 1 tick mark, 2 tick mark, 3 tick mark, and I have R, T, S, 1 tick mark, 2 tick mark, 3 tick marks. So this is our congruence statement. Okay, and the beautiful thing about once you write your congruent statement correctly, identifying all the pairs of congruent corresponding parts becomes much easier, and I'll tell you why. So let's do part B. And I'm going to clean up the diagram real quick so we can draw on it again. Okay, so we want to identify all pairs of congruent corresponding parts. So all pairs, that means I'm going to have pairs of angles, and pairs of sides. So here's the thing. We can look at our diagram and say L has 1 tick mark, R has 1 tick mark. Angle L is congruent to angle R. And we can look at our diagram and say angle J has 2 tick marks, and angle T has 2 tick marks. So angle J is congruent to angle T. We can keep doing this. We can keep listing the corresponding parts in this fashion. We can also look at our congruent statement. And because we wrote our congruent statement in order, 1, 2, 3, 1, 2, 3, I can also just say, L comes first, R comes first. So L is congruent to R. I can say J goes second, T goes second, angle J is congruent to angle T. And I can say angle K comes third, and angle S comes third, so angle K is congruent to angle S. So you can look at the diagram and match J and T, L and R, or you can look at your congruent statement. Do whichever is easiest for you. I'm not saying that one is better than the other. The one that is better is the one that works better for you. Okay. Now, when it comes to sides, we can do the same thing with the sides that we did the angles. I can look at the diagram and say, 1 tick mark, 1 tick mark. So J, K, from 2 tick marks to 3 tick marks, J, K is congruent to 2 tick marks, 2 tick marks to 3 tick marks, is congruent to T, S. And I can look at my diagram and say from 1 tick mark to, from 1 tick mark, what am I doing here? Okay, 2 tick marks, the side with the 2 tick marks, there we go. Side with the 2 tick marks, I can go from 1 tick mark on my angle to 3 tick marks on my angle. I can say that RS is congruent to 1 tick mark to 3 tick marks is congruent to LK. As long as I go in the same order, as long as I go, I'm looking at the side with 2 tick marks, but I gotta go in the same order. I can't say RS and KL. I need to say RS and LK, because we go from 1 tick mark on the angle to 3 tick marks on the angle in both cases. Now, if you switched both of these, if you said SR and KL, you'd be fine if you switch them, because SR goes from 3 tick marks to 1, and KL goes from 3 tick marks to 1. So it doesn't matter the order that you write them in, or excuse me, it matters the order that you write each of them in, but if you, as long as you switch both of them, you're fine. You're fine. So we can totally do this by looking at the diagram. The other way that we can do it is by looking at our congruent statement. J and K are right next to each other. They're 2 and 3. And TS are right next to each other. They're 2 and 3. So JK is congruent to TS. We can also say that SR, you can think of this as kind of wrapping around the third and the first. SR is congruent to KL, if you're thinking about it as wrapping around, right? K goes back to L when we say L, J, K. K goes back to L when we say L, L, J, K. Okay, you get it. So, S goes back to R, K goes back to L. So we can say that SR is congruent to KL. And there's one pair of sides we missed. We haven't talked about the 3 tick marks. And we can look at our diagram and say, okay, RT, LJ, or we can look at our congruent statement. LJ are right next to each other. RT is right next to each other. So we know that LJ must be congruent to RT. So we can take 1 and 2, we can take 2 and 3, and then we can take 3 and 1 and wrap them around like that. So we had LJ and RT, JK and TS, and then if we wrap around, we get SR and KJ. Or KL, excuse me. Ooh. So you can use your congruent statement to find the corresponding parts that are congruent, or you can still just look at the diagram, whichever is easiest for you. But do note something that I want to point out. How can you check your answer? Well, a nice quick check is if you have a triangle, that means that you have 3 sides. It also means that you have 3 angles. So when you write out all pairs, you should have 3 pairs of angles and 3 pairs of sides. If you don't, you're missing some, because triangles have 3 sides and 3 angles. So that's a good way to quickly check yourself. Okay, actually no, we'll leave that there. Okay, all right, let's check and make sure that we were correct. J and T, K and S, L and R, JKTS, KLSR, LJRT. Woo! Yay, we were right. Okay, on to example 2. Properties of congruent figures. So, in the diagram, these 2 shapes, or quadrilaterals, since they have 4 sides, these 2 quadrilaterals are congruent. We're told that they are congruent. And hey, if they're congruent, all their corresponding parts are congruent. Now, they didn't color code for us, and they didn't give us any tick marks, but we can see that F is like the most small, it's the smallest angle, and Q is also the smallest angle. And E looks like, let's let's see, I don't know if it's the biggest angle. I think D might be the biggest angle. Yeah, D is the biggest angle. But E is, it has this shape. It kind of goes up on this side next to the smallest angle, F. So we know that E matches with P. And another way you can think about it, in fact, a better way to think about it, perhaps, is what if we redraw this shape? Let's flip this shape so that it looks exactly like the other shape. So, I know they're congruent, so I know that they need to look exactly the same. Let's see, this left side is a little too slanted. So they both need to look exactly the same. They both need to look like this quadrilateral. Now we just need to relabel. So F and Q are both the smallest angle. That gives us the 6y plus x for the angle Q right here. And then the flat side, I can see that QR is the flat side. And QR is 2x minus 4 feet. So make sure that you transfer all of the markings in your diagram when you redraw the picture. And then let's see, P, so it goes up from S to P. So if we're going up from S to P, that means that S needs to be on the bottom and P, whoops, not R. P needs to be at the top. So if you can think of taking this quadrilateral, SPQR, and turning it, right? We just turned it or rotated it 180 degrees. Clockwise or counterclockwise. It's the same when we do 180 degrees. Okay, but now it's so much easier to see. F goes with Q. And E goes with P. It's so much easier to see now. So, now that we know which angles, which sides are corresponding, we can find the value of x and find the value of y. Now, the reason that redrawing the picture helps and knowing what the corresponding parts are is because if two shapes are congruent, then their corresponding parts are congruent. So, Q is congruent to F, E is congruent to P, D is congruent to S, and G, whoops, is congruent to R. And likewise with their sides, EF is congruent to PQ, DE is congruent to SP, GD is congruent to RS, and GF is congruent to RQ. Now I know our diagram is looking a little messy, so let's get rid of some of these colors. What do we want? We want to find the value of x and to find the value of y. First, let's look at the value of x. Where is x? Let's see, here has an x and a y. I'm not dealing with y right now. We're just gonna look at x first. So the side that has just an x in it, 2x minus 4, this is side RQ, the side with 4 tick marks. That corresponds with side GF, or the side with 4 tick marks. So, look at that. I know that 2x minus 4 needs to be the same as 12. The sides are congruent, which means that they have the same length. So, for part A, I know that 2x minus 4 needs to equal 12. The green sides need to be the same. So if I add 4 to both sides, 2x equals 16, and then if I divide by 2 on both sides, I get x equals 8. Awesome, we found the value of x. Done with part A. Okay, now part B, let's get a different color. Find the value of y. Now let's go ahead and look at the angle that has the x and the y. Because we figured out x. We know x. So 6y plus x is angle Q. Well, we know that angle Q is the same as angle F. And actually, I'm going to get rid of the green so that we can see a little bit better. I know that angle Q is the same as angle F, which means 6y plus x needs to be the same as 68. 6y plus x needs to be the same as 68 because they are corresponding. They're both in the bottom right. Same relative position. Okay, now you might think, what? How am I supposed to solve for y and x? We don't need to solve for x because we already did. So let's take this x, we'll plug in 8 for x, and we have 6y plus 8 equals 60. We'll subtract 8 from both sides, 6y equals 60, and we'll divide by 6 on both sides, so y equals 10. Yay, we found the value of y. We are done. We could check by plugging everything back in, but for the sake of time, we're just going to check by looking at the solution. 12 equals 2x minus 4. Perfect, that's what we did. And 68 equals 6y plus x. And we got 10 equals y. Perfect. Perfect. That's what we did. Okay. We have one last example to do, and it is about the third angles theorem. Remember, our learning target and success criteria talked about corresponding parts, which we just learned about, and the third angles theorem. So this is the last part of our learning target and our success criteria. So, if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So if A and D are congruent and B and E are congruent, then we automatically know that C and F are congruent? Pause the video and convince yourself that this is true. Think it through. Why should this be true? Pause the video, think about that, unpause it, let's talk. So, if two angles are the same, then the third one should be the same. So the reason that this makes sense is we know that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. And the same is true for our other triangle. The measure of angle D plus the measure of angle E plus the measure of angle F should equal 180. But if, so because they both equal 180, you can say that they're equal to each other. So measure of angle A plus the measure of angle B plus the measure of angle C is equal to the measure of angle D plus the measure of angle E plus the measure of angle F. But wait, we know that A and D are the same. So they cancel out, right? If I subtract measure of angle D from both sides, it gets rid of it over here, and it gets rid of it over here, because A and D are the same. And the same goes for B and E. If I subtract the measure of angle E from both sides, it cancels out over here, of course. It also cancels out over here. And if we had more space, we would actually do the substitution of B and E are the same. B and E are congruent, so you can just replace B with E. And same thing, you can replace measure of angle A with measure of angle D. So you see how they cancel out a little bit better. And then we're just left with the measure of angle C equals the measure of angle F. So actually what we did was a proof. We just did a proof. It wasn't the cleanest, nicest proof, but we just did a proof of the third angles theorem. And if you thought through this same reasoning, well, you kind of proved it in your head. So awesome. Let's keep going. Let's do our last example for today, using the third angles theorem. We are asked to find the measure of angle F. The measure of angle F. I'm going to put 3 tick marks here because these already have 1 and 2. I can't just put 1 tick mark here, or you're saying that E and F are the same. And we don't know that. We don't know that E and F are the same. So I want to find the measure of angle F. But because A and B are the same as D and E, I know that C and F are the same by the third angles theorem. If 2 angles of one if 2 angles of one triangle are congruent to 2 angles of another triangle, then their third angles must be congruent. So if I can find the measure of angle C, well, I know that's the same as the measure of angle F. And we can find the measure of angle C. We know that the angles in a triangle add up to 180 degrees. So 40 plus 100 plus the measure of angle C equals 180. That's 140 plus the measure of angle C equals 180. So if we subtract 140 from 180, we get 40 degrees. 40 degrees. So if C is 40 degrees, that means that F is also 40 degrees. And hey, look at that. We could actually get rid of one of these tick marks because angle A and angle C are actually the same. For this example, that will not always happen. That will not always happen. Okay, wonderful. So the measure of angle C is 40, which means that the measure of angle F is 40 because of the third angles theorem. Wonderful. Okay, that is all I have for you today. Thanks for watching the video all the way to the end. Well, there's still more, so don't stop watching now. If you have questions, everybody has questions. It's normal, totally normal to have questions. Yeah, you're not any less smart if you have questions. But you are, well, I shouldn't say you are, you're not less smart, but smart people get their questions answered. So if you have questions, don't just let them sit in your brain. Get them answered. Understand the answers to your questions. So if you have questions, please ask. Also, take this time to check your understanding of the learning target and the success criteria. Do you know what corresponding parts are? Do you know what the third angles theorem says? And can you use them to solve problems? Check yourself, see how you're feeling about it. Now, these are some problems you can do to check your understanding of what we learned about in this lesson. But do the homework your teacher assigns, as usual. And our launch for today comes from Lucille Ball, and she says, "Love yourself first, and everything else falls into line." This is something that I took a little bit of time to learn, and to actually truly learn. Because I loved my parents first, or I loved my boyfriend first, and I didn't love myself first. And the problem with that is, if you don't love yourself first, if you don't take care of yourself, you can't really give love to other people. It's like if your ship is sinking, how can you help somebody else's ship? Right? If it's sinking, you can't help somebody else's ship, yours is sinking. So make sure that you are taking care of and loving yourself. Speak love to yourself. And ask yourself, if you have a thought, say, was that loving to myself? When you look in the mirror and you go, oh, my thighs are too big. Is that loving to yourself? No. No, it's not. You look in the mirror and you say, wow, I am perfect the way I am. I am beautiful the way I am. Or handsome the way that I am. Speak love to yourself. Love yourself first. And everything else falls into line. Treat yourself well. Treat yourself like you would your best friend. You wouldn't look at your best friend and go, "Ooh, your thighs are too big." No! No, 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 no. You would say, "No, you're beautiful." And talk to yourself the same way. So, that is my launch for you today. Love yourself. Please do, because you're very, very lovable. So, that's my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.